Today in this session, let us see cutoff frequencies and filter characteristics of rectangular waveguides. Cutoff frequencies and filter characteristics. Myself, Dr. V. Vijayasri Bolsetti, Associate Professor, Department of Electronics and Communications. So, what is a cutoff frequency? So, in the waveguides, we have seen that some of the signals are allowing to propagate through the waveguides in TE modes, and some of the modes are not propagating in the rectangular waveguides. For example, if you have seen TE and TM wave equations, for m is equal to 0 and n is equal to 0, either TE wave or TM wave do not propagate through the rectangular waveguide. And all the remaining modes, for example in TE modes, higher order modes like TE with m and n different values like zeros and ones are propagating through the rectangular waveguides. So, all these modes may be having a different frequencies, and what are the modes that are allowed to propagate through the rectangular waveguide is nothing but we are going to determine the cutoff frequency in our today's class. So, what is the learning outcome? So, at the end of this lecture, the student will be able to determine the cutoff frequency of any propagating mode in the rectangular waveguide. Okay. So, let us derive the cutoff frequency. So, we know that the propagation constant gamma is equal to some alpha plus j beta. So, to derive this propagation constant gamma, it is we go through our equation, that is h square is equal to a square plus b square. So, where h square is nothing but gamma square plus omega square mu epsilon is equal to h square. This we have used this equation in deriving the TE and TM wave equations, where this gamma is the propagation constant and omega square mu epsilon is equal to h square. So, now this h square is also equal to a square plus b square. So, what is a and b? These arbitrary constants we have derived for the TE and TM wave equations, where a is equal to some n pi by b and b is equal to m pi by a. So, by substituting all these together, we can obtain some equation for this gamma square, So, let us substitute this a is equal to n pi by b and b is equal to m pi by a, and in this gamma square plus omega square mu epsilon is equal to a square plus b square. So, we are going to get the expression that gamma square is equal to, since from this equation we got the relation that it is gamma square plus omega square mu epsilon is equal to a square plus b square. So, from this we can obtain gamma square is equal to a square plus b square minus omega square mu epsilon. So, let us substitute that a and b in place of a n pi by b whole square n pi by b, and in place of b we substitute m pi by a. So, gamma square is equal to n pi by b whole square plus n pi by a whole square minus omega square mu epsilon. So, what is this gamma? So, actually if you say this gamma is the propagation constant, and this propagation constant as if the gamma is the propagation constant, we can obtain this gamma as square root of n pi by b whole square plus m pi by a whole square minus omega square mu epsilon. So, that is some root value, square root value. So it is going to say that if the root value is positive, you are going to get the gamma is a real value, and if the root inside the root value, if it is negative, you will get the imaginary. So this gamma can be a real and positive coefficient, or it can be a imaginary coefficient. So that is the reason why we have defined this gamma simply as equal to, it may be a real value or it may be a imaginary value. So simply we can write it as alpha plus j beta. Okay. So this, as this gamma is some root of this root value may be, if this n pi by b plus m pi by a whole square, if this value is greater than omega square mu epsilon, it is going to result a positive value under the root, and so results the alpha, attenuation constant alpha. Suppose if this value n pi by b whole square plus m pi by a whole square is less than omega square mu epsilon, then automatically this entire value becomes a negative value in the root and results a imaginary part. So it is a combination of attenuation constant and beta, we can consider it as the phase constant. So here alpha is the attenuation constant or attenuation coefficient, and beta is the phase constant. So simply we can say the propagation constant gamma can be expressed in terms of attenuation constant and the phase constant. Okay, so we have seen that sometimes it may be resulting a attenuation constant, or sometimes it may be resulting a phase constant. So for what are the conditions that it is going to see? See, as we have seen that at low frequencies, that means when omega is small, we can say that as omega is small, this value can also be a small value. So omega square mu epsilon can be less than n pi by b whole square plus m pi by a whole square. In such case, the root value is a real and positive. So we are writing that the gamma square will be greater than 0 because it is real and positive. So obviously as gamma square is greater than 0, then we can say that it is going to result some real coefficient, some real value. So because of this gamma can be equal to simply alpha. That means if in this case, if the gamma is equal to alpha, this is showing that this particular frequency is going to face some attenuation, So because of that, this frequency signal is not allowed to propagate through the rectangular waveguide full-fledgedly. So because it is going to offer some attenuation at this particular frequency. So this is the condition that is showing, right, this is the condition that is showing that at this condition, that is at low frequencies, that means for frequencies omega square mu epsilon less than n pi by b whole square plus m pi by a whole square, we are not able to propagate that signal. Okay, so gamma becomes real and positive and equal to the attenuation constant alpha. Therefore the wave is attenuated and there is no phase change, hence this wave cannot propagate through the rectangular waveguide. So now let us take at high frequencies what happens. So at high frequencies, that means if this omega square mu epsilon is greater than n pi by b whole square plus m pi by a whole square. Omega square mu epsilon is greater than n pi by b whole square plus m pi by a whole square. At these frequencies, as this term is greater than this, that means what is our gamma? Gamma is equal to root of n pi by b whole square plus m pi by a whole square minus omega square mu epsilon. So now what we are saying this is this omega square mu epsilon, that means this negative term is greater than this term. So obviously the resultant is going to say there is a negative value in the root, there is a negative value in the square root. So this negative value, this root of minus is going to result the imaginary term, is going to result the imaginary term. So it is, we can say that now this gamma is equal to some j beta, and it is do not have any real and attenuation coefficient, real and positive coefficient. So here we can say there is no presence of alpha, that means here alpha is equal to 0. As alpha is equal to 0, we can say that there is no attenuation, there is no attenuation present, and hence as there is no attenuation, that wave, the signal whose frequency is omega, can propagate through the rectangular waveguide because it is simply having only the phase constant and there is no attenuation constant. So let us see that in this case, as gamma is less than 0, it is going to give imaginary coefficient, and hence it will be phase change is beta, and hence the wave propagates through the rectangular waveguide. So at the transition, that means previously we have discussed both the cases, that means in a particular case for low frequencies that omega is small, and hence we are going to get the attenuation, and at high frequencies omega is large enough, and hence the wave propagates through the rectangular waveguide. That means frequencies, low frequencies it is attenuating, and high frequencies it is allowing. So simply we can say, for example, if you consider these are the low frequencies, and as the frequency increases in this way, let us consider this is the high frequencies and low frequencies. Suppose if you have any division of low and high frequencies, so there is attenuation present here and there is no attenuation here. So because of no attenuation, so simply this wave is going to propagate through the rectangular waveguide. Because of attenuation, there is no propagation here. That means it is attenuating low frequencies and propagating the high frequencies. So we can consider that it is just like a high pass filter with some cutoff frequency. So we need to determine what is that cutoff frequency. That means for low values of omega, there is attenuation, and for high values of omega there is propagation. So there is a transition, it is taking that, it is changing from attenuation to propagation, there is a transition takes place. So this transition occurs at the frequency, and that frequency we call it as cutoff frequency, we call it as cutoff frequency. Okay, so we define, that means at the transition that omega itself becomes cutoff frequency. So here this is the case where omega is small, omega square mu epsilon is less than some m pi by a whole square plus n pi by b whole square, and here omega square mu epsilon is greater than m pi by a whole square plus n pi by b whole square. So at this transition, this condition is going to be equal. That means at the transition omega square mu epsilon will be equal to m pi by a whole square plus n pi by b whole square, and we call, that is when this is equal, that means in the root value, that is if you take gamma is equal to root of n pi by b whole square plus m pi by a whole square minus omega square mu epsilon. If these two parts, positive part and negative part, equal, then this will get cancel, and the gamma is going to be equal to 0, and this gamma will be equal to 0 only if omega square mu epsilon is equal to n pi by b whole square plus m pi by a whole square, and at that case this omega is nothing but equal to omega c, because at the transition the frequency, we are calling that frequency as the cutoff frequency. So either at f is equal to fc, or we call that omega is equal to omega c. So we are replacing this omega here as omega square mu epsilon is equal to n pi by b whole square plus m pi by a whole square. So let us consider this is our equation 3, and so now we got the relation for omega c, cutoff frequency. So from this we can obtain what is omega c from equation 3. So what is omega c? Omega c is equal to root omega square mu epsilon. So bringing mu epsilon to this side and applying the square root. So you are going to get square root of 1 by mu epsilon n pi by b whole square plus m pi by a whole square, and this omega c can also be written as 2 pi fc. Omega c is nothing but equal to 2 pi fc. So bringing this 2 pi to this side, we will get fc. fc is equal to 1 by 2 pi root 1 by mu epsilon n pi by b whole square plus m pi by a whole square. So now this, what is this 1 by mu epsilon under square root? So we already know that c, the velocity of light, is equal to 1 by root mu epsilon. So here we have this root 1 by mu epsilon is nothing but equal to c. So simply we can write fc is equal to c by, and in this we have the pi term common. So if you take this pi as common in the square root, you will get root pi square. So root and pi square can be written as pi, and that pi will get cancelled with this pi, and so simply we are going to get c by 2 root n by b whole square plus m by a whole square. Okay. So that means if you take this pi as common simply and write this 1 by mu epsilon under the root as c, you will get it as c by 2 pi root of, if I take pi square as common, you will get n by b whole square plus m by a whole square. So root pi square, we can write it as pi, gets cancelled with this, and so we get fc is equal to c by 2 root n by b whole square plus m by a whole square. Okay. So this is the relation for the cutoff frequency. So as we have discussed earlier, so we are going to say at low frequencies, that is frequencies less than this cutoff frequency, okay, those signals with those frequencies are going to face the attenuation, and the signals whose frequency is greater than this fc will be allowed to propagate through the rectangular waveguide. We will see this further. So what type of filter it is going to represent? As we have seen that as the wave propagates, the condition for the wave propagation is omega square mu epsilon should be greater than n pi by b whole square plus m pi by a whole square. It is going to show that, that means in the previous equation we have seen this n pi by b whole square plus m pi by a whole square is nothing but equal to omega c square mu epsilon, is nothing but equal to omega c square mu epsilon. See, yes, it is nothing but equal to omega c square mu epsilon from equation 3. So let us substitute the same. So that is this n pi by b whole square plus m pi by a whole square as omega square mu epsilon. So we are going to get the condition that omega square mu epsilon is greater than omega c square mu epsilon. This indicates if you cancel this mu epsilon on both sides, we can say that omega square should be greater than omega c square. That means or omega should be greater than omega c. That means the frequency should be greater than the cutoff frequency. So f should be greater than fc. So at this condition we are going to get the wave is going to propagate. That means the frequencies which are greater than fc are allowed to propagate through the rectangular waveguide, and the frequencies which are less than fc are attenuated while propagating through the rectangular waveguide. So based on this condition, that means if you again draw the characteristics and if you represent this is some fc, so these are the frequencies which are less than fc and these are the frequencies which are greater than fc. So the frequencies which are less than fc are going to attenuate, so this is going to show the attenuation, and the frequencies which are greater than fc are simply allowed to pass through this. That means this is the propagation. So this is alpha and this is j beta, and generally we write gamma is equal to either attenuation or propagation takes place. So gamma is equal to alpha plus j beta, and this characteristics is representing simply it is a high pass filter. It is a high pass filter. So as it allows all the frequencies greater than fc, we can say that the rectangular waveguide allows all the frequencies greater than the cutoff frequency, and hence rectangular waveguide acts as a high pass filter. This is the summary of this cutoff frequency.